This is week 5, lecture notes. We're going to start with the topic geometric sequences. So, grab a separate sheet of paper. We're going to do a little background information first. Geometric sequences are a sequence of numbers in which there's a pattern that's established by multiplying over and over again by the same number to get the next number in the sequence. So, geometric sequences. We're going to do 2 examples. Here's our first example. Let's start with the number 1 and multiply that by 2 to get the next number in the sequence. 1 times 2 is 2. Let's multiply that by 2 and we'll get 4. If we multiply 4 by 2, we get 8. If we multiply 8 by 2, we get 16, and let's just do it once more. Multiply 16 by 2 and we get 32, and we could keep going and going on into infinity. So each successive number in the sequence is calculated by multiplying the last one by 2. Couple of definitions here. This number that we're multiplying over and over again is called the common ratio. So in this sequence, our common ratio is 2. Alright? We're also going to be developing a form for finding any number of a sequence. So if we look at this, here's what we did to get, for instance, the 6th term. 1, 2, 3, 4, 5, 6 term. 1, 2, 3, 4, 5. 6th number in the sequence. We started with 1 and we multiplied that by 2, right? To get 2. So that'll make 2, and we multiply that answer by 2 to get the 4. And then we multiply that answer by 2 to get the 8. Multiply that answer by 2 to get the 16, and multiply that answer by 2 to get the 32. So let's take a look at what we did. We took our initial value 1 and we multiplied it by 2. How many times? 1, 2, 3, 4, 5. 2 to the 5th power, and that gave us the 6th term. So to find a sub 6, that means the 6th term, we did our starting amount times our common ratio, that was what we were multiplying by over and over again, raised to not the 6th power but the 5th power, one number less for the power than the term we're finding. Alright, now let's do that in general terms, because what if we wanted to find the 10th number in the sequence instead? Well, we'd use the same process, but we'd go a sub 10 is equal to our starting amount times 2 to the 10 minus 1 power. And then we would get our answer. Let's double check to make sure this works though. 1 times 2 to the 5th power, so it's really just going to be 2 to the 5th power, because anything times 1 is just that thing. So 2 to the 5th power, that is indeed, whoops, let me go back for a second, that is indeed 32. It seems to be working. Let's try it for the 10th term. A sub 10 should be our starting amount times 2, not 10 times, but 1 less than that, 9 times. And let's check out and see what 1 times 2 to the 9th power is. 1 times 2 to the 9th power. We don't really need to times by 1. We get 512. So let's extend this pattern. 7th term will be 32 times 2, which is 64. The 8th term will be 2 times 64, which is 128. The 9th term will be 2 times 128, which is 256. And the 10th term will be 2 times that, which is indeed 512. So the formula works. Let's put it in general terms now. To find any term in a geometric sequence, we're going to take the initial amount, the starting value, which we'll call a sub 1, term 1, times that common ratio. We have a special letter for the common ratio. We call it r. And to what power? To whatever this number is, whatever term you're trying to find, but take away 1. Go back 1 notch. And we'll be using this formula over and over again, so put it on your note card.